Hello everyone, welcome to the course Network Theory, and this is Dr. Satyavani Bandela, Assistant Professor, SR University, Warangal, Telangana. So in today's lecture we are going to discuss mesh analysis with different combination of sources, that is current and voltage sources. In previous lecture we discussed the same mesh analysis and what are the steps and how to analyze, how to write mesh equation in any loop. Okay, so those things with simple two loop network we discussed in previous lecture, and here I'm telling that part, that is though the lesson number 6 it is there, that is I have divided that into two parts. The part 1 is the previous lecture, now this is lesson number 6 part 2, because here we are going to discuss the same mesh analysis for 3 loop and with the different placing, that is voltage and current sources. If the current voltage sources are connected between the loops or at the end, how to develop this mesh equation, that part here we will discuss. Now let me share the previous lecture slides. In previous lecture I explained this two loop mesh equation, two loop circuit diagram with two different sources and three resistors, and what are the steps that we need to take to develop this mesh equation. And the first one is identify the number of loops and represent unknown currents with loop 1, loop 2 in clockwise direction, and develop mesh equation using by applying Kirchhoff's voltage law in every loop, and solve those equation, and finally find out loop currents. Now I will share those equations whatever we discussed in last class. So this is how we have to develop loop equation in loop 1, and algebraic sum of voltages, that is the voltage is taken as minus 2 plus it is, if I write this a simplified equation, and you will get V1 equals to I1 into R1 plus R3 and minus R3 into I2, and this is the loop 2 equation, and loop 1 equation 1 and 2, this is your equation 1 and 2 can be written in matrix form like this, and enter these values in calculator, directly you will get answer I1 and I2 values. Clear? So this part up to here we have discussed in the last class. Clear? Okay, if you want a clear explanation, you go through that previous video, lecture number 6 part A. Now in this lecture number 6 part B, we are taking 3 loop equation with only voltage sources. See here in this example circuit, there are two voltage sources. Let me represent those voltage sources here, and there are two voltage sources. What are they? One is 150 volt and another one is 50 voltage source. Okay, and the remaining all are resistors. Okay, and see the position where the voltage sources are connected. Here this is connected in loop 1 at the end, and this is connected in loop 2 at the end. Okay, now so the first step in mesh analysis is identify number of loops. There are 3 loops, and here I am taking, this is loop 1, represent loop 1 current with I1, and this is loop 2, and loop 2 current with I2 in clockwise direction, and similarly loop 3 current with I3. So first there are 3 loops and represent I1, I2, I3 current in respective loop. Okay, then the second step is apply mesh analysis. So apply mesh analysis is nothing but it is an application of Kirchhoff's voltage law. Here I am applying mesh analysis in individual loops. So I am applying KVL in loop 1. So the first one is in loop 1. Loop 1. So what is that? So here I told in last previous lecture, that is you take, it is better to take voltages at left side and voltage drops right side. Okay. Now in loop 1, what is loop 1? 150 volt, 20 volt and 10 ohm. So in loop 1 there are 3 elements, one is voltage source and 2 are resistors. Okay, only one voltage source is there, and here we are crossing this minus to plus. So when you are crossing from minus to plus, remember that plus. Left side I am writing 150. Okay. Now if I write this IR drops left side, it will be, you have to write minus, but here I am writing this IR drops right side, so that's why plus. Now see, so how many resistors are, the number of resistors in loop 1 are 2. So what are they? 20 ohm and 10 ohm. Now first I am writing voltage drop across 20 ohm. So what is the current through 20 ohm? This is same as I1 current. So this loop current is same as this branch current. So here I am writing the voltage drop across 20 ohm is 20 into I1 resistance into current. The next plus, then another after 20 ohm, what is the element? 10 ohm resistance is. Then what is the current? Now this 10 ohm is connected in between loop 1 and loop 2. We are writing equation in loop 1, so that now current is taken as I1 minus I2. 10 into what is the current? Now it is I1 minus I2. Clear? Now rewrite this equation. See here I am writing. So better here, let me take first I1 drops, 30 I1. Why I am writing I1, I will explain later. So 30 I1 and the next minus 10 I2 and 120 here I am writing 120, 150, sorry, it is 150. Okay, so better see, just take IR drops left side and voltage drops right side. Okay, so let me interchange this voltage IR equals to V. Okay, now what is your second loop? Now here I am writing the loop 2 equation, loop 2, mesh analysis in loop 2. Again, now first I am taking IR draws, algebraic sum of voltage drop across the resistors equals to algebraic sum of voltage sources. Okay, in loop 2, what are the resistors? Which resistors? What are the different resistors which are connected in loop 2? 10 ohm, 30 ohm, 50 ohm. Now while writing drop across 10 ohm, you have to take like this, 10 into, now the current is I2 minus I1, because we are writing equation in loop 2. That's why this is I2 minus I1. If you are writing this drop in loop 1, here we have written I1 minus I2. So this is written in loop 2, because 10 is connected between loop 1 and loop 2. You will get this IR drop due to 10 ohm in loop 1 as well as in loop 2. Okay. Then after 10, what is the element? 30 ohm is there. Then what is the current? It is I2. Okay. Now plus I am writing all IR drops left side, 30 into I2. Okay, we will follow the same in for the next problem also. Okay, the next, what is the resistive element? That is 15. Now plus 15 into, now see the 15 branch, the 15 ohm resistor. Now this is connected between I2 and I3, means loop 2 and loop 2, loop 3. So it is connected between 2 and 3. That's why what should I write? Current through this one, I2 minus I3, because I am writing loop 2 equation. That's why I have to subtract I3 from I2. So now the current through 15 ohm is I2 minus I3. So 3 resistors in loop 3, 3 drops. Do you have any voltage source in loop 2? Is there any voltage source? So from here, let us start from here. 10 ohm. Look at this. Let me. 10 ohm, 30 ohm, 15 ohm. There is no voltage source. Is it right? No voltage means here I am writing 0 right side. No voltage source. Now rewrite this equation. First write I1, the next I2, the next I3. Okay. Now simplify this equation. Minus 10 I1 then I2, 10 I2, 30 I2 and 15 I2. So number of I2s here, the total I2 value here it is 40, 55. So it is plus 55 I2. The next I3 is minus 15 I3 equals to 0. This is your equation 2. Okay. Now let me write equation 3 here. So that is in loop 3. Loop 3. Now here onwards we will follow this IR drop equals to V. I will explain why I am taking this. IR, sigma IR equals to sigma V. Now look at this. So number of resistors in loop 3, 1, 2, 3. The first element is 15. So what is the drop? IR. Resistance is 15. What is I? Current. Now what should I write? We are writing in loop 3. And where 15 is connected between 3 and 2, now we have to write I3 minus I2 because we are writing this drop in loop 3. So that's why first you have to write I3 because we are writing in loop 3 minus I2. Okay, because 15 is connected between I3 and I2. Okay, now this is I2. Then plus, what is the next element after 3, 15? What is the next element? 10 is there. Okay. Now plus 10 into, now what is the current? Current here, this current is same as I3 current. This current is same as I3. 10 into I3. Next, what is the next element? 20 is also there. Then plus 20 into I3. Now 3 resistors, 3 voltage drops over left side. And the next right side. Now number of voltage sources in loop 3, only one voltage source is there. This is plus and this is minus. We are moving in clockwise direction. See here we are crossing this plus to minus, or we are leaving this with negative polarity. That's why minus 50. Clear? Now rewrite this equation. First write I1 coefficient, I2 coefficient, then I3. So I1, I2, I3. Do you have any? There is no I1, but I2 is there, minus 15, I2. The next I3 are, this is 25 and 45 means it is plus 45 I3 equals to minus 50. This is 3. So equation number 3. Now see how to solve it. If you solve this equation, it takes I think 2 minutes, but if you use your calculator, it takes within 10 to 15 seconds you can solve this. Then how to enter these coefficients? Let me show the calculator and I will explain how to enter these values in calculator and how to get the solution for these 3 equations. See here, I am taking, what are the unknown parameters? I1, I2 and I3 are unknown parameters. Okay, and the constants are voltages. Okay, so here I am writing constant or voltages. So let me take another color. This is I1, I2, I3. Okay, and constant. Okay, now take this. See here I am taking equation 1. First equation 1. In equation 1, what is I1 multiplicand here? It is 30, right? 30. What is I2 multiplicand? Minus 10. And what is I3? Do you have I3 in this equation 1? No I3. Means it is 0. 0 I3. Then what is the constant? 150. Okay. So first equation, coefficients. The next second equation. What is your second equation? This is your second equation. This is your second equation. Then what is your I1 multiplicand here? Minus 10. See, minus 10. This is equation 2. Then I2 multiplicand here, it is 55. Then I3 minus 15. Then constant 0. Minus 10, 55, minus 15, 0. So these numbers here I have entered from equation 2. Then from equation 3, so this is our equation 3. Okay, 15 minus 15 I2. Do you have I1 in equation 3? There is no I1. So means, what should I write here? 0. Right? There is no I1. That's why we have to write 0 I1. Then I2. I2 multiplicand is minus 15 and I3 multiplicand is 45. And what is the constant right side with the voltage source? It is minus 50. See, minus 50. First of all, develop this table from the equation. Now I will explain how to enter these values in calculator. Okay. If your calculator is this one, let me share this. If your calculator is this model, that is Casio FX 991 ES Plus. Okay, so first select your mode of operation. So in mode of operation, the equation, the respective number for equation is 5. So EQN, for 5 number EQN is there. So then press 5. Okay, so when you press 5, then here I think it is not clear. If you press 5 in your calculator, it will show number 1 is ANX plus BNY equals to CN. And second, number 2 is for ANX plus BNY plus CN Z equals to DN. And third one, AX square plus BX plus C equals to 0. Okay. Now out of 4 equations, these 3 equations are in the form of ANX plus BNY plus CNZ equals to constant of DN. Okay, means number 2. Now our 3 equations are like equation number 2 equation ANX, because here X, Y, Z are 3 unknown parameters. Here in our equation, what are the unknown parameters? I1, I2 and I3. I1, I2 and I3. 3 are, it is considered as X, Y, Z. If only 2 loop equation is there, then you have to take ANX plus BNY equals to CN. I1, I2 only you will get, and you have to take ANX plus BNY equals to CN. But here it is a 3 loop equation, that's why we have to take ANX plus BNY plus CNZ equals to DN. That is the respective number here, it is 2. So you press 2. Okay. Now it will ask you to enter the quotients or the multiplicands of x, y, z from equation 1, 2 and 3. See here in first row, here it is showing the first one. Look at this. So this is the first row and this is the first element that I am going to enter. Clear? So here I am entering the first number. In this, here it is 30. Okay, first you press 30 equals to, then it will ask you to enter the y coefficient. What is that y coefficient? B. B value here it is minus 10. Minus 10 minus 10 then equals to, means the third number 0 equals to the next number 150. So like enter all these numbers one by one. 30, you press 30 in this, then equals to, then it will move to next place, next position, then minus 10 equals to, the next is, it will, when you press equals to, it will move to the next position in calculator. Okay, so like you enter one by one. 30 equals to minus 10 equals to 0 equals to 150 equals to minus 10 equals to 55 equals to minus 15, like up to minus 15. Now let us enter the second row. Here I am entering second row. Minus 10 equals to 55 equals to minus 15 equals to 0 equals to. Now it will shift to third row. You can see this third row in your calculator. Now I am entering third row elements. 0, first one is 0. Third row element, first one is 0. The next equals to, the second element is minus 15. Minus 15 equals to 45 equals to minus 50. Okay, now here I entered minus 50 after I am pressing equals to in calculator. Now it will show minus 50 only. Okay, now again you have to press equals to 2 times. Okay, equals to. Now in your calculator it will show x value. Okay, so x value here it is 110 divided by 21. Clear? And this value is 5.23. What is x actually? It is I1. Now this is I1 current. I1 current equals to 5.23 ampere. Okay, we got this. Now note down this. Now again press equals to in calculator. Press equals to. Now it will show y equals to. I am writing this here with violet color. Now y equals to, it is showing 5 by 7. Okay, now this value 0.71. so actually what is y here? I2. Is it right? So this is y is I2, x is I1, y is I2, z is I3. Okay, now we got y value or I2 current. How much? That is 0.71 ampere. Okay, now third. Now again press equals to. Now I got z value. What is z here actually? I3 current. I3 current equals to minus 55 by 63, and that magnitude is minus 0.87 ampere. Clear? Now we got all three currents. What are these currents? These currents are loop currents. Okay. Now look at this. Here I will take same circuit. In next slide I will explain. Or else I will erase this. Here itself I will explain loop current and branch current. Exactly what is mean by, what is the difference between the loop current and branch current. Look at this. After getting I1, I2, I3, and how to identify the loop branch current in terms of loop current. Now see, here I am taking green color. See here, this is I1 current. Is it right? Means from here this is I1. Clear? Current through 150 is I1. Current through 20 is also I1. Now this is loop 2. Here up to here this is I2 current. And this current, this is also I2. And this current is I1. And up to here this current is I2. And according to this direction this current is I3. And I3 like this, I3 means this is also I3. This is also I3. This is also I3. Means now I am writing. Now look at this. What is current through 20 ohm? How much current is flowing through 20 ohm resistance? I1 current. Okay, what is I1 here? We got 5.23 ampere. So 5.23 ampere is flowing through 20 ohm resistance. Even what is current delivered by this 150 voltage source? Again, I1. Okay, so through 150 the current is 5.23, that is I1. Okay, now well, when it comes to the middle branch, I 10 ohm, now this is connected between I1 and I2. Okay, if I take the direction exactly, whether it is downwards or upwards, look at this. For example, if I am taking the direction of current, this is through this branch. See the difference, this is loop current, but this is branch current, exact branch current. I don't know exactly what is the current. I am taking Ix. Okay, Ix. Ix may be I1 minus I2 or I2 minus I1. When I am taking this current downwards, Ix. Now here you take KCL. Now this current here it is leaving current I1. Here I am writing leaving current I1. Let us take leaving current. Leaving current minus I1. Here I am applying KCL. Now this current is towards node. This current is also towards node. Okay. This is leaving the node. That's why minus I1. Then what should I take? Ix plus Ix, because this is towards node, entering the node, and this I2 is also entering the node, means plus I2. So three branches are connected together. Here I am applying KCL. Okay. Now from this you will get Ix. This is algebraic sum of currents equals to 0 according to KCL, and from this I can write Ix equals to what? I1 minus I2. Whether you can apply here or here, you will get same answer. So what is Ix? I1 minus I2. Okay. Now I'm taking I1 is 5.23 minus I2, how much it is? 0.71 equals to 4.52. Now the original branch current through 10 ohm resistance with what direction? Downwards direction. Okay, downwards direction. How much current is flowing? 4.52 ampere. Okay, 4.52. Now tell me, what is the current through 30 ohm? I2. What is current through 10? I3. What is current through 20? I3. Then what is the current through 15? If I take downwards, this current equals to I2 minus I3. Like how we applied KCL here, similarly we have to apply this KCL at this node. Leaving current equals to entering currents. Leaving current equals to sum of entering currents. So I2 equals to 15 plus I3. Okay, current, let us take 15 ohm resistance IV. I2 equals to IY plus I3. Okay, now this IY is equals to I2 minus I3. If you take this, you will get some number that current is flowing through 15 ohm resistance with what direction? Downwards direction. If you take upwards, you will get different. Okay, so that's why the branch currents, based on the direction you will get whether it is I2 minus I3 or I3 minus I2. Okay, so like this, if you have a network with 3 loop with voltage sources, you have to solve this network like this. Now let us take one more simple example with the current source. Okay, here I am taking 3 loop circuit and see the positions of the sources. First of all, I am taking one voltage source 120. Okay, let me take here itself another voltage source with example I am taking. Here I am assuming 10 voltage source, and this is 5 voltage source. Let us take, there is no gap here, it should not be there. I mean 5 voltage. Okay, so that will get practice. Now observe, first step here, one loop 1. First step is identify number of loops and represent current I1 loop 1, and in loop 2 current I2, in loop 3 current I3. Clear? Okay, now I am writing mesh analysis in loop 1 equation. Mesh in loop 1. Okay, so that let me write the IR draws first, then next right side voltage. So current 15 into I1, 15 into I1, and now 45 into I1 minus I2 plus 45 into I1 minus I2. Then after 45, what is the resistor? 60. 60 into I1 minus I3 plus 60 into I1 minus I3. So all resistors I have written left side. Now look at this voltages in right side. See, sigma IR, voltage drops at left side I am writing, equals to voltage sources, algebraic sum of voltage sources right side. Now in loop 1, there are two voltage sources. The one is 120 voltage source and the another one is 10 voltage source. See in this loop. So now 120 we are crossing from negative terminal to positive terminal. This is short length is negative and long length is positive. So now minus to plus means it is plus 120, and in our direction now we are moving this 10 voltage from plus to minus, that's why it is minus 10. Minus 10. So voltage sources I have written plus 120 minus 10 due to this source polarities. Now rewrite this. This is 45, it is 4, 60, 60, 120, 120 into I1, and then next minus 45 into I2 minus 60 into I3 equals to, this is 110. Okay, this is our equation 1. Now I am writing loop 2 equation here in loop 2 mesh analysis. Now see, IR drops at left side and voltages at right side. Now first here I am starting from here, 10 into I2, 10 into I2. Then what is there any other resistor? Yes, in loop 2 55 is there, then next 45 is there. So plus 55 into, now current is I2 minus I3, I2 minus I3. Now the drop across 45 is plus 45 into I2 minus, now it is connected between I2 and I1. So loop 2 and loop 1, I2 minus I1 equals to 3 resistors over. Now I am writing the voltage. In loop 2 only one voltage source is there, and that too we are on the way, we are crossing this from plus to minus, that's why it is minus 5. Okay, now rewrite this equation. Minus 45 I1. Now this is 65, it is 110 I2, then minus 55 I3 equals to minus 5. This is our second equation. Now see the third equation, it is very important. In loop 3, see this is in between 1 to, we can write I3 minus, but here it is I3 minus, but here original branch current is there. How much current it is flowing? 2 ampere, and here this is the loop current and this is the branch current. Both are in opposite direction. Okay, Now actually this loop current is same as this branch current with the same direction, I3 will be like this. Okay, but original branch current is upwards with magnitude of 2. That's why in loop 3 we should not write any KVL because we don't know voltage across 2 ohm, or the intention of writing mesh analysis itself finding current. Direct I3 is given, I3 is known how much, that is 2 ampere with opposite direction. So that's why I3 directly it is written as -2. Okay, if this current is, let us represent this current with the downwards. Now here I am writing with the different color, red color, let us take. If this current is downwards direction, okay, then I3 is same as 2 ampere, I3 is same as plus 2 ampere, but in the problem it is represented upwards. So that's why I am taking minus I2. Okay, so what is I3? It is minus I2, minus 2 ampere. Now substitute these values in calculator and determine loop currents. Then next later find out the branch currents. So with this I am closing, and 3 loop we have finished. 2 loop mesh equation, 3 loop mesh equation with voltage and current sources. In next video we will see the same, we will apply the mesh analysis but changing the position of current. If current is connected in between the loops, how to develop, how to write mesh analysis, and that part we will discuss in next session, and that is your super mesh analysis. Okay, until you just get practice, takes few problems and practice those problems using mesh analysis. So with this I am closing. Thank you.